So my name is Miguel Pastor, and I'm going to talk about our experience porting from iOS games into Chrome Web Store. I'm one of the co-founders of Onan Games, and we are a small company, only 5 people. It's only engineers, no design, no art. So we have been doing porting for already 2 years. We started doing some PC games porting into iOS, some Wii games, and we decided to move into HTML5. So we started to port C++ iOS games into HTML5. What we have is a technology called Mandreel. So what we think is we have 2 kinds of developers. We have high-level video game engines that those developers use. They can be Unreal Engine, Unity 3D, and other high-level engines. And we have other developers that they write their own engines, and they use low-level libraries. They use C++ or JTC. That's the reason we created Mandreel, to convert these video games to the web. So it should be easy for iOS developers, Android developers, console developers to move into the web, HTML5, Flash. So what's Mandreel? It's a framework, not only a compiler. What I mean is like the compiler helps to convert from C++ or JTC into JavaScript, ActionScript. But we support OpenGL ES 1.1, 2.0, OpenAL, libc. So most of the libraries that C++ developers are used to work with. It works in all the browsers. If you want to target Internet Explorer, just use the Flash backend. If you want to target Chrome, you can use the WebGL backend or even the Flash backend. It converts your code from C++ to JavaScript or JTC, and it's all automatic. You don't have to change anything. You don't have to tweak your code. If it compiles on C++, you will get the JavaScript or the ActionScript working. For example, it's really easy for iteration. So you do some change in your iOS game, add a new functionality, new feature, you just compile again, and you just generate the JavaScript file. So conversion process is only a few days. So it's faster, less time, less money, and publish faster. We are only 5 developers, and we ported 9 games in 4 months. So if you go to the Chrome Web Store, you can check the games we already ported. You can play this game right now if you want. So we have Monster Dash. It's a quite popular iOS game. We have Great Little War Game, some games from Glue, Gun Bros, Beat and Guster, Contract Killer. We have Mad Skill Motocross, Back Village, another game from Glue, a Space Shuttle for free, and Crawl. So already 9 games, ported in 4 months. They are like the same version, same assets, same code. The same thing as the iPad version. So all these games have been like C++ games. So lately we added support for JTC. So we have Cocos 2D games running on HTML5, Flash. So I don't know if you know this game, Continuity 2. It's a Cocos 2D game working on a WebGL. Let me see. This is a simple 2D game, but it's the same code. It's a JTC. We have a tool, converts a Xcode project, and it can generate a Visual Studio solution, and you compile it. And the game runs. It's a Cocos 2D example using WebGL. This is another example. I don't know, you know GT Racing from GameLoft? It's a 3D racing game. So this is the iPad version running on WebGL. This is an old machine. It works, everything is around 30 frames per second. A 3 years old MacBook Pro. And you see, the game is running. And it has a multiplayer, 8 players. It works on Firefox as well. And we're using all the latest technology, web audio, file system API. So this is another sample for the most complex games we have been ported. So the game you saw before was the GT Racing game. So I'm going to talk about the process from moving from iOS into HTML5. These are the tools we use. Of course, Mandreel framework to help us with the problem of the language, the problem with C++. We use Google App Engine, SDK, for hosting the games. WAM server for testing. Microsoft Visual Studio 2010 and 2008, and Mantis Backtracker. We had several challenges with iOS video games. The iOS games are installed applications, so it's something the user, he will wait for the download. For example, the GT Racing game is 500 megabytes. So you want to play the game, you have to wait to download those 500 megabytes. The version we have on HTML5, it does everything streaming, so you don't have to wait. So the first time you play, you have to wait for 5 megabytes to download, and the rest is going to be streamed. The game progress is stored in the device internal memory. That's something, it doesn't work quite well with web applications, because you expect to play the same, game in different computers. The games, they use C++ or GTC. Most of the games, they use OpenGL ES 1.1. They use the Apple Store API for in-app purchases, OpenAL for sound. They use Game Center for leaderboards, achievements. They have sockets. They have TCP and UDP sockets. You can open a new window. You can open a new browser inside your iOS game. You have Facebook. You have touch controls. Most of the game, they use Flurry for events tracking. Install apps. User installs application on the device internal memory. As I told you, user downloads game from the Apple Store. And installation time depends on the game size. I mean, some of the games, they have 20 megabytes, but we have games that are 1 gigabyte. Only happens once. So you download it, and that's it. iOS games, native applications, they use fopen, fret, and it's all synchronous. They don't care. I mean, it's fast. So that's something on the web, it doesn't work that way. They don't care about the size. It's 1 gigabyte, it's OK, no problems. And they don't have problem with the maximum number of files. Again, they can have 4,000 files, and it works. For the Chrome Web Store, we have two options for applications. We have package applications, that we will talk about this later, and we have hosted applications. That's just a normal website. So we started the first games we ported were using manifest cache. For Chrome, the default size is only 5 megabytes. But if you install the application, you get unlimited storage. The application cache is just a static list of resources. And you can access those resources using XML HTTP request, and you can ask for a synchronous loading. That's important because it really helps you to make a port easier. because the C++ game, they use all the fopen, fret being synchronous. So with XML HTTP request, you can. So this is a typical application manifest catch. So you have all the resources. You have this version number that you can change. So this is, for example, for the Gun Bros game from Glue. This is the resources that the game is using. How we did the thing with the manifest catch? So what we did, it was, we waited for the manifest catch to finish. So we knew that everything was in the catch. So we had a problem with that, a lot of complaints from the users. That some of the games, they had to download 300 megabytes. So you had to wait for 300 megabytes to download. So during that time, you can update the user to see what's going on. So you can use the progress event. Every time a new file is downloaded, you get this event. So you have your application catch has 20 files. Every time a new file is downloaded, you get this event. What can happen as well is you are playing the game, and the developer, they decide to upload a new update. So inside the game, you will get a prompt asking to reload the application, so you can start the game with the latest update. So the thing is really typical in the web game is updating the game. So you can update the game once a week. So what happens when you update the game? You have to change the manifest catch file. But what's the problem? Even if you only change one file, the manifest catch is not smart enough, and it has to download everything. So that was quite bad, because sometimes you only change one script, and the user had to download the whole game. And in the case we have this 300 megabytes game, it was quite bad, because we just wanted to tweak something, and the user it has to download 300 megabytes. We have more limitation with manifest catch. We are using App Engine. App Engine, the maximum file size is 32 megabytes. So you have a big pack file, 100 megabytes pack file. You have to split it in files smaller than 32 megabytes. So for the new games, we are using File System API. It's a sandbox file system. You can create files. You can delete files, but only works on Chrome. The way it works, you ask for quota. Let's say this game is going to use 200 megabytes. So the user gets a prompt in the browser asking, this game is going to use 200 megabytes storage. You want or you don't want? So if the user says yes, you can save things locally. The main problem with this, they don't have asynchronous API for reading files. So it means we had to do things to make it work with the original C++ games. So what we did to have a faster downloads was packing all the files in a big file. Because you get a performance penalty when you have for each HTTP request. So your game has 300 files, and you want to download 300 files. It's going to be slower than you have one big file with all the files packed. So what we did is we pack all the files together. We compress it using lset.ma. We use HTTP request to do async loading. We uncompress it, and we store the uncompressed data using File System API. So your game is using 40 megabytes, 80 megabytes, so just compresses. Sometimes like 20 megabytes, 30 megabytes, compress, you uncompress it, and you store in the file system storage. Because iOS developers, sometimes they don't care about compressing the data, because when you upload something into the Apple Store, it gets compressed using zip. So we are using something similar, but we use a better algorithm. We use lset.ma. So we did a really easy solution to fix the problem with asynchronous loading. So what we did was keeping all the data in memory. So your data is 20 megabytes, so we keep all the assets in memory. So we can do FRED synchronous, it works. For the GT racing game, we didn't do like that, because the game is 500 megabytes. So what we had to do is, we had to rewrite the code. We had to prepare the game engine to support streaming data. So with File System API, we want to update the data as well. What happens if we want to release a new version, if we want to tweak something in the game? So we have in App Engine, we have a file with the last modification time. So every time we want to upload something, we change this file. And inside the client, we are using the get metadata from File System API to compare the time from the server and the time you created the file locally. There is an important thing that you have to be careful on File System API. When you create a new file, it doesn't delete the file. So for example, you just save a file, it was like 500 bytes, and the new file is 400 bytes. If you create the file, and you save the file, and the file originally was 500 bytes, and the new file is 400 bytes, the file in the File System API is 500 bytes. So you had to remove first the file to be sure that after saving the file, it's going to have the right size. So game progress. iOS games store the game progress into the internal device memory. That's OK. You always carry your phone. You play with your phone. So it's OK. You can store there, no problems. On HTML5, you can use local storage. It saves the data into your browser internal memory. But what happened with that? I mean, people play at work. They go home. They want to continue playing. Or they use a laptop. So that's not a good idea. So we decided to use cloud saving. So we use App Engine federated logging. That's something like using your Gmail account. You can save unique data into App Engine. It's important, the thing with cookie expiration to use 1 week. Because if you use 1 day, sometimes it only lasts for half an hour, 1 hour. So we have problem, and we have some clients complaining that after playing 1 hour, they couldn't save the progress anymore. It's because the 1 day expiration, it doesn't work properly. So use 1 week, so you will not have problems. So this is a simple example that we use inside App Engine to do the game progress saving in the cloud. So just the App Engine code. Just saving using the users, get current user. Get current user is something like inside App Engine, you can ask for the current user, the one that typed the credential. So we use that user to save the data. And for C, C++, or GTC, how we solve that? Using Mandreel. The Mandreel files are huge. 10 megabytes, 12 megabytes JavaScript files. We have a problem with App Engine. App Engine doesn't compress JavaScript files bigger than 1 megabyte. So in the end, we have 12 megabytes. Like you compare using gzip, should be around 1.5 megabytes. So you are wasting a lot of bandwidth. So we decided to use LZMA. So we compress the JavaScript file. We load it using XML HTTP request. We uncompress it using a JavaScript solution to uncompress the JavaScript. And we store the uncompressed one using File System API. There is something important as well for the Mandreel generated JavaScript. We don't have the problem with garbage collector. So the code converted using Mandreel, it doesn't have this problem. So usually we didn't have many performance problems with the games we ported. OpenGL ES 1.1. So most of the iPhone games, they still use the old API. But WebGL is an OpenGL ES 2.0, so it doesn't support fixed pipeline. So what we did, we added support, Mandreel, for OpenGL ES 1.1. So we emulated the fixed pipeline using shaders. So we generate, at runtime, we generate shaders, so we don't have to rewrite the graphic engine. They can use OpenGL ES 1.1. We support frame buffer objects, vertex buffer objects, and we support as well the user memory data. So as you know, on WebGL, you can only use vertex buffer or index buffer. But usually, iOS developers, they don't use vertex buffer. So we had to add support for that. And the texture format on iOS, most of the developers use PBR texture. Right now on WebGL, you don't have support for that. So we added support for that into Mandreel. But the decoding is really slow. I mean, the JavaScript cannot handle that. So we had to change the texture for all the games. Some of them, they were using PBR, so we changed it to PNG. In-app purchases. So some of the iOS games, they use StoreKit for in-app purchases. So it's really easy. You just go to the Apple server, set up the price, set up the description. It's really easy. You don't need to write server code. You just call it, say, the user clicks to buy something, and you get a callback with the result. For the Chrome Web Store games, we use Google in-app purchases for the web. You need to call Google API to buy something, but it opens a new window. You need to write server code. That's something like, it's not, you use Android in-app purchases, you don't have to write server code, but here, you have to write server code. We did this using an app engine, solving the problem with in-app purchases and the server code. So what we did is having the server being able to describe your virtual items, the price and the description. For example, this is a capture from a space shooter from Frima. So this is inside App Engine. So it's really easy. So you just want to change the price of your items, or you want to change the description, just go into the App Engine, change it, and that's it. And the game, the next time you play the game, you will see the updated in-app item. This is the code we are using to generate the in-app purchases token for Google iApp. So it's really simple Python App Engine code. So with in-app purchases, we have a problem with pop-up blockers. So when the user clicks on the WebGL view, first, we try to call the Google API. So what the Google API does is opens a new window. And because it's not a native HTML button, the pop-up blocker, it blocks the window. So that's a problem. So what we did is a really simple solution. I will show you a demonstration. Oh, I think I have a crash with Chrome. So what we did is like, so you have the WebGL view. So when you want to buy something, you click on the WebGL button, and we change to HTML window. So inside that HTML window, you have a native button, so the pop-up blocker doesn't work. So this is it's an OpenGL ES 1.1 game. It's using Lua for scripting, and it all works. We are using Flash for this game for sound. So this is the in-app purchases window. As you see, it's WebGL. So what we did is when you want to buy something, you click here, and we open an HTML window. So you don't have the problem with pop-up blockers. So you press buy, this is HTML button, and it works. You don't have the problem with pop-up blockers. But it's an additional click. That's the problem. OpenAL. iOS games, they use OpenAL for sound. With OpenAL, you have pitch support, you can create sounds, you can load sound from resources, and you use MP3 for streaming. We started with HTML5 audio tag, but it didn't work. We tried to load 30 different sounds, and Chrome crashed. It works fine with music streaming, but it doesn't work for games. So what we did two implementations. One for Web Audio, another one for Flash. Web Audio is a Chrome-only API, and it's really great. It supports all the OpenAL features. So it's really simple to implement, and it really works. We tried with Audio Data API. It's a Firefox-only API. You had to do all the software mixing for all the sounds. For example, you want to implement pitch, you have to do the software mixing. But what happens? For each reason, I don't know, you are loading something, you are compressing something. If that frame, it takes 500 milliseconds, you are going to get problems with your audio. And you cannot use web workers because you don't have access inside the web worker to Audio Data API. And you have the latency. If you do software mixing, you get 150 milliseconds on Windows. For Flash, it works on Firefox Chrome. It doesn't have pitch support, so we added software mixing when you're using a channel with pitch. Flash is really great because it works in a parallel thread. So you have the JavaScript running, and you have the Flash running, doing all the software mixing. So you have a multi-threading machine. It will use your other core. Latency was a problem on Flash 10. They have a problem on Windows. So doing software mixing, you have the problem with 150 milliseconds latency. They fixed that on Flash 11. So another cool thing that iOS developers use is Apple Game Center. With Game Center, you have leaderboards, achievements, you have lobby, and you have a network layer. You don't have anything like that on web. So we had to use our own solution. So using App Engine to save the leaderboards, achievements, we had to write custom achievements leaderboard viewer. Because usually with developers, what they do with iOS games, they just call Game Center to show the leaderboards and achievements, and they don't write a single line. So we had to implement that. Sockets. This is something like another typical thing from iOS developers. They use HTTP requests to communicate with the server. They use RESTful API to send data to the server and get data from the server. iOS games, they use TCP sockets. They can use libcall or custom libraries to communicate with the server. But on HTML5, you have native support for RESTful API. You can use XML HTTP request. But we have this problem, cross-origin resource saving. This is the most horrible thing I mean, I didn't know about this. I mean, like, so you have the problem with applications hosted in example.com. They cannot access data in example2.com. We didn't know about that. So it's like when we did some of the schedule for the games, we didn't know about this. So it was quite painful. I mean, like, because native applications don't have this restriction. And for HTML application, server code needs to be changed. But it's really easy when you have access to the server code. But what happens when you don't have access? So you have to write a proxy. Because sometimes, like, you have your client, they have their server technology, and they don't want to change anything because it can be a risky solution, or they don't want to mess anything, so you have to do everything in your side. So you have to write a proxy. So using App Engine, you can write a proxy. So you can do a HTTP request to your own server, and from your server, using Python, you call your client server. And it works. So you don't have the problem with the cross-origin resource sharing. But the bandwidth is going to be higher. So it means more costing, more money. UDP sockets. Fast-paced games, they use UDP sockets. It's like peer-to-peer technology. iOS, you can use UDP sockets, no problems. But right now, there is no support for that on web browser. There is no technology for that. So we had to change the UDP sockets to TCP sockets. And you cannot do peer-to-peer. So what it does mean? That you have to write a server, a replace server. So it means that the latency is going to be worse, and you need bandwidth. And bandwidth means money. So it's another problem. So we change it to TCP sockets. And for TCP sockets, we have support for flash TCP sockets. For the server, they need to support flash socket policy files. It's really easy. You can send binary data, no problem. It's the same protocol as TCP. And we use external interface to communicate JavaScript and Flash. But the problem, you can only send strings. So you have to use base64 to encode the data. So WebSockets is the native solution. It works natively on HTML5. But you need to change your server code. You need to support the new handshake protocol for WebSockets. And you cannot send binary data right now. I mean, they will fix it. I don't know, it's like Chrome 16 or, no, but I don't know which version, but right now you cannot send binary data. So what does it mean? That your server code has to handle base64 data. So it means more changes. And sometimes your clients, they don't want to do any change. So you have to use flash TCP sockets. Facebook. So some of the iOS games, they use Facebook Connect. It's a really nice library written in GTC. So for the JavaScript version, we use the JavaScript SDK. It has the same functionality as the iOS version, but we have a problem again with the pop-up blocker. So when you call Facebook login, it opens a new window. So we did the same solution we did as with in-app purchases. So when you want to connect to Facebook, you go to a HTML view, and you have to click on the HTML button. And we had another problem with Facebook. Again, the infamous course problem. You have the Facebook picture. So it's really, so you want to get the Facebook picture from your friends. So you use the API from Facebook. You just use HTTP request to get the picture, but it doesn't work. Why it doesn't work? Because they use the trick with sending a 302 response. What do you mean? They use a redirect. They redirect the URL to a different server, and this server doesn't support CORS, so we had to use another proxy. It's called Super Proxy Facebook. So with this proxy, you solve the problem with Facebook picture. Simple code, the same thing. So we had to use a lot of proxies. It was the problem. touch controls. So iOS games, they use touch controls and accelerometer. You don't have that on web applications. So we need to change the code, and we need to tweak the controls. That's something like, but it's normal when you're doing a port. For analytics, I mean, you are writing a freemium game. It's normal to track events. All our clients, they're using Flurry Analytics. So we changed it to use Google Analytics. It's a really simple API, no problems there. So we have some App Engine issues that with static files, if you use static files in App Engine, you cannot use custom headers. So it means you cannot solve the problem with cores. And the maximum size for static files, so you need to use application files. The problem with application files is the maximum size is 150 megabytes. And you have, don't remember, 3,000 or 4,000 limitation for number of files. So how we solve that? We use blobs. So we pack all the files into a big blob. The maximum is 1 gigabyte, and we use blob byte ranges to share those files. But what's the problem? When you're using blob byte ranges, you get a 206 response. It's OK, you're writing the code, so you just check for that in your XML HTTP request. But if you want to use audio tags, it doesn't work. So we had to do with some games like the audio, we were using the normal application files, but for the rest of the files, we had to use blob byte ranges. So this is some of the code. This is an example using the solution for having like more than 150 megabytes files. So this is like a normal, just a simple App Engine code. So now let's talk about package applications. So the first time we started working with a Chrome Web Store, we started using a package application. It's some kind of like, it's similar to the Apple Store. When you upload something, you upload a huge CRX file, and it has everything. And it's using zip for the compression. So you don't need to host your application. So you just upload it, and that's it. But it has a lot of problems. You cannot communicate between Flash and JavaScript when you're using a package application. You cannot make Facebook to work because it's a local site, so it doesn't work. And AdSense doesn't work neither. So we had to change in the end to host applications. So we had some issues with WebGL as well. Not all the Chrome users can run WebGL. So the statistics we got, it was around 25% games installation can play the game because WebGL. Because the users are using all drivers. Even the computer is DirectX 9 compatible. You cannot run WebGL because the all drivers. Users, they can override the behavior using Chrome flags. You can override the software rendering list. So for all computers using all drivers, you can make it work. The script is taking too long, but where? We don't know. If you use Firefox, it tells you where. The file and the line. So it's really helpful, Firefox, but it doesn't work on Chrome. We want low-C texture with alpha channel. We want faster JavaScript engine, and we want threads. Web workers are nice if you want to calculate P, but that's it. You cannot do anything with them. I mean, with write, OK, we can do all the rendering in a web worker. So you cannot access GL context. You cannot access web audio context. So right now, for us, it's useless. So we want improved package applications. We want Facebook to work using package application. We want cloud storage, AdSense, and we want a more simple solution for in-app purchases without using server code. And that's it. Any questions? That's it, one question. So only one question.
So this is amazing. I mean, you worked around so many problems in order to do this, what seems to be an impossible porting and translation task. If you knew back when you started what you know now, would you do it again?
Yeah, of course. I mean, it's so interesting. I mean, right now we are having the same problem. We are using new technologies, and we are having, again, new issues. We try, okay, it works. You do this, it doesn't work. So it's like, it's always interesting, like using new technologies, and you know when you're using new technologies, like things are not going to work, are going to be buggy, but that's something like, that's something we like, so that's the reason we are doing this.